Excellent story. Congratulations. I will talk about digital transformation, and during this discussion, I will discuss how AWS and Aquasight is partnering together. But let me frame the problem first. If you go to the next slide, please. There are over 52,000 water utilities, 16,000 wastewater treatment plants in the US alone. And globally, obviously, you can multiply that by 4 or 5 times. Every day, terabytes of data is being created, and there's 10 different types of data sets that are generally available in these utilities. And there's a big gap on how to capture this information, integrate it, mine it, predict from it, and act on it in a way that you can drive resiliency and you can have a ESG level compliance and requirements be met. So what we have done at Aquasight, if you go to the next slide, please, is we have deployed in over 120 cities and villages and townships in partnership with AWS, a series of solutions that allows the complete automation and solving problems of a variety of different problems. So for example, pump health, we saved about 30% of energy used in pumping water using a digital solution that we've launched. Predicting water quality, which neighborhoods are going to have bad water quality. Detecting leaks, which homes have anomalies in their consumption, whether it's due to toilets leaking or your swimming pools leaking. Managing pressures in the system. Any big change and fluctuations in pressure is potentially an indication of a main break or even leaks in the system. Water conservation, a huge topic on the West Coast, accounting for every drop of water. Regionalization is a mega trend in this industry. So in fact, one of the case studies I will talk about is how Aquasight launched a system that covers 112 communities across 1,800 square miles. Sewer monitoring, as the climate change occurs, sewer overflows, combined sewer overflows is a big issue. How do you monitor? How do you measure the levels and the flows and bring intelligence as to how these sewer systems are reacting to storms? What are the blockages in the system? Forecasting flows. And jointly with US Department of Energy, we deployed an intelligent wastewater treatment plant system at one of the largest plants in the country, from which we've actually spawned off a whole series of plants that we've deployed the solution. Intelligence around your assets, critical assets such as pumps, blowers. It's very important to have them in good condition. And how do you use sensors and how do you leverage data mining to be able to know which assets requires maintenance or rehab or replace? And then finally, risk asset management planning, which is essentially a risk scoring of every asset in the system. We deployed a solution that would use intelligent but also best practice engineering formulas to know which assets needs to be replaced which year. And finally, during COVID time, we also deployed, and we still have, in over 6 counties, we're monitoring the level of COVID within underground, essentially in the sewer pipes. So these are the kind of solutions Aquasight has deployed it, and we brought this solution set, if you turn to the next slide, please, through 6 main packages or modules. Now, this is where AWS really comes into play. When Aquasight got started, we just started with one solution, Atlas. And we knew we were going to eventually cover the entire water cycle. So we want a partner that can scale with us, but more importantly, a partner that can meet stringent cybersecurity standards. And I've worked in Fortune 500 companies. I know many of the utilities in general cannot afford cybersecurity experts on their own, but even Fortune 500 companies cannot afford as much as what AWS can have. So in that sense, they truly are, gives us a safety net in terms of ensuring our solutions are compliant with the highest levels of cybersecurity threats. Now, this solution set has been launched, as I mentioned, in 120 cities. But one of the unique features of this is that it can plug with any data set, whether it's SCADA, GIS, individual telemetries, smart meters, modeling tools, lab information system, environmental data, etc., depending on what capability you need. The other thing I want to bring up is SAMI. Most utilities, they are resource starved. They just don't have enough people. So you can't have people staring at the computers and trying to detect what the issues are. So SAMI is like a digital employee that would mine through information and understand which are the indicators that could potentially be problematic in a water system or a wastewater system, and would notify. So it's kind of a smart alert of how human thinks and brings multiple parameters together. And I'll walk through a few case studies on this. Go to the next slide, please. So this is a first of a kind in the US. Great Lakes Water Authority is a system that serves 3.8 million residents, have close to 1,800, 1,700 square miles. And one of the things is they supply to 112 cities. And what happens in these is that as the water is being supplied, once it transfers over to individual cities, the water quality, the flows and pressures really depend on that city's demand. So they wanted to create a smart platform that could predict water quality, detect pressure anomalies, account for live and daily flows, have detection for which homes are leaking. But they want to do it in a way that's fully automated. So that's where Aquasight worked with Great Lakes Water Authority. We brought this innovation to them, and it's been rolled out over the course of the last 3-4 years across all these communities. But one of the things we discovered along the way is that how it can retain the knowledge of how the system behaves. See, most of these 112 utility leaders, they either retire or they move to the next city. So when you want to have the system, they can look back what happened 3 years ago, 5 years ago, in a matter of few seconds and few clicks. So this way, the speed at which someone can ramp up is dramatic. In fact, normally they say in an industry, it will take 2 years to ramp up. And now we cut it down to 2 weeks for anyone to ramp up what's going on in their system. And lastly, as you know, anybody who dealt with government, the procurement is a huge issue. And this totally eliminates inefficiencies with procurement because these 112 cities do not have to go to their individual city council. If anyone is interested in this case study, it's been published in AWWA Journal, 2022, May, and along with the CEO of Great Lakes Water Authority. Go to the next slide, please. This is on the wastewater side. It's a fascinating case study. As you know, the intensity of rain and the frequency of rain have changed quite a bit due to climate change. And what this is creating is a problem where it's flooding the underground pipes, or sometimes these floods actually, they overflow onto the streets or onto our river creeks. And there's a huge amount of storm analysis that gets done. Data gets crunched on many of these. So what we have built by using a rain gauge network with Macomb County, close to 1 million residents, is the ability to have a past storm intelligence, live storm intelligence as it's happening. And now we're soon launching a forecasted storm intelligence. And what this is trying to do is giving a full heat map on what the intensity of the rain is in each one of the locations or each one of the districts or communities within that county. And for example, if there is a 25-year, 50-year rain is occurring as we speak, then that the county public works can actually divert the resources in that direction, saying, hey, there's a potential for flooding in that area. Let's move our resources in that. But it also, the system automatically captures the start of a storm event, end of a storm event, and you can go back and map this heat map for any one of those 100 storm events, for example, that's happened over the course of the last 2-3 years. So it's a very excellent way to drive complete automation and remove the need for an engineer to crunch all this data. But more importantly, if you combine this with what's happening in the flows and levels of sewer system, it gives you a complete picture of where potentially the flooding might happen. So this has been a great success story and a great demand for something like this as it pertains to resiliency. Go to the next slide, please. This is a case study on asset risk scoring. We've done this for several communities. We risk profile each asset. What used to take months to develop these plans, now it takes weeks to develop. And more importantly, it eliminates the need for expensive engineering hours. There's in general a shortage of asset engineers in the country, and this is a great efficiency play. What I liked about this particular case study is you can run 5-year, 20-year, or 10-year capital planning scenarios in minutes, what normally takes hours and days to run. It's something that is one of the biggest trends that we see in this industry, which is asset risk scoring and capital planning. And finally, if you go to the next slide, please. One of the exciting parts for me in the last 1 year is just having the opportunity to team up with AWS and the role they have played in giving confidence to our customers, which are obviously very concerned about putting stuff in the cloud and cybersecurity. When we did this press release of this partnership, we are public sector competency. We are on the marketplace where cities can easily procure. We're also met all their FDR requirements, etc. When we put this press release up, 330 local agencies picked up the news across the country. That tells me the interest, A, on intelligent water solutions, B, on Amazon's position, and C, what role we can play all together. So with that, I would like to turn this conversation over to Don. Thank you for hosting, and happy to take any questions.
Thank you, Mahesh. We really appreciate